All right, welcome back. In this section, we look at what are called improper intervals. Here in section 8.9, improper intervals. And improper intervals are intervals that result when we have an interval that's continuing out towards infinity. Now, if you're dealing with just a normal everyday function like a parabola like this, and you were going off to infinity, well, it's going to have an infinite amount of area. No big deal. None. But if we have a function where we're approaching a horizontal asymptote, then we ask the question, does that have a finite amount of area or an infinite amount of area? Now, your initial thought would be, oh, it's got to always just be infinite, right? Actually, turns out answer is no. It actually depends. It depends on how quickly that function, which will never actually reach, in this case, 0. It depends on how quickly it gets there. If it gets there quick enough, it's never going to actually reach it, but if it gets close quick enough, then you actually can, as we're going to see, can have a finite area. So this is one example of what's called an improper interval, where we're going from a value out to infinity. We would write that as the integral from a to infinity of f of x dx. So that's one of our situations where we're going to be dealing with an improper interval and understand what that means and how we can actually compute that and know if the integral actually goes, is the integral actually infinite, or is the integral some finite amount? Some finite amount. That's what we're going to try to figure out. The second time that we can talk about what's called an improper interval is when you're trying to integrate as you approach a vertical asymptote. And once again, you may at first seem like, well, that's going to be an infinite amount of area, right? It actually, again, depends on how it's approaching infinity. It actually depends on how it's approaching infinity. And so this improper interval would be written, we would say, the integral from a to b, but b is a vertical asymptote place. And we're going to talk about how to evaluate something like that. So those are our improper integrals. And here's the idea here. So we're going to talk about the integral going to infinity first. I want you to kind of understand how that idea works. So I want to just copy the picture that I had from before. So I'm just going to take that and bring it down and copy it here, because I want to explain how integral from a to infinity, how it actually works, what we understand it as. So for the integral from a to infinity of f of x dx, this infinite integral, what we do is we consider the integral from a to b of f of x dx and take the limit, as b goes to infinity. Take the limit as b goes to infinity. So the visual picture looks like this. I just need to do a little adjusting here. Get rid of that blue and mark a value here, b. Right? So we talk about that integral first, right? And then take the limit as b goes to infinity. So we allow b to go to infinity. Right? And that's how we can talk about that infinite integral. That's how we can talk about that infinite integral. We first talk about computing the finite integral and then doing the limit of that result. And we'll use a similar idea with the vertical asymptote. We'll say, the integral from a to c, and then take the limit as c approaches b In this case, it would be from the left. C approaches B from below. And so that's how we'll talk about that one later on. But for now, we're going to focus just on the ones going to infinity or minus infinity first. And then we'll turn around later and look at those ones that are approaching a vertical asymptote. So this is the idea of how we talk about these infinite integrals, which are called improper integrals, either approaching a horizontal asymptote as we go to infinity, or approaching a vertical asymptote on one of the sides. Okay, so we're going to pick up and look at some examples of this idea in the upcoming videos, but I first wanted to just kind of give you a little understanding of how we set up and focus on these problems.